Okay, so we will continue with section 5.4. Section 5.4, inequalities. Okay, so this is recording 2. Okay, so last time I mentioned that I want to go back and solve 2 more examples of polynomial inequalities. So let's talk about more examples of polynomial inequalities. So the first problem which I want to solve is from your textbook. This is page 373, number 49. So solve algebraically. Solve polynomial. Inequality. Okay, and we have nice inequality because it's already in factored form. X plus 1 times x minus 3 times x minus 5 greater than 0. Okay, so step 1, solve equation. Since everything is already on the left side, so just solve equation. So we want to find those x-intercepts, zeros of the equation, x plus 1, x minus 3 times x minus 5. Make it equal 0. Since you already have all the factors, this one should be very fast to solve. Make each parenthesis equal 0. You're solving 2 simple equations. X minus 3 is equal 0, x minus 5 equals 0. So we're getting x equal negative 1, x equal 3, x equal 5. So having those 3 numbers, what you're going to do, you're going to create intervals. Step 2. Build 4 intervals. Since you have 3 zeros, you have 4 intervals. Build 4 intervals on number line. Okay, so I'm creating the number line. Again, we're solving polynomial inequality in terms of x. So you have x equal negative 1 will be here, x equal 3, and x equal 5. Okay, don't forget that our polynomial inequality has a strict inequality. We're looking for the solution for which the polynomial inequality is greater than 0. Since it's a strict inequality, what we're going to do, x equal negative 1, x equal 3, and x equal 5 won't be part of the solution. So our 3 zeros is breaking down the number line into 4 intervals. Here we have negative infinity to negative 1, from negative 1 to 3, from 3 to 5, and from 5 to positive infinity. Step 3, just do the test. Step 3, test each interval. Okay, so we're going to test it. Let me just copy the same number line. Negative infinity, positive infinity, we have negative 1, 3, and 5. So I'm going to check which of the 4 intervals will be the solution. So let's test the first one. Here from negative infinity to -1, test something what is less than -1. So let's make x equal -2. And what you're going to do with that, you're going to plug it in into the original inequality. So we have, going back to the inequality, again, x plus 1 times x minus 3 times x minus 5 should be greater than 0. So parenthesis. Okay, so we have x plus 1, so we have -2 plus 1 times x minus 3 for x, I'm plugging in -2, so you have -2 minus 3 times x minus 5, which will be -2 minus 5, and again I'm checking if that will give me something positive. So when you will solve that, we're getting -2 plus 1, which is -1, times -5 times -7, and that will give you -35, which is not positive. Okay, so this is not true. Not true. So what I know that the first interval won't be the solution of that inequality, and I'm going to do exactly the same work 3 more times. So I'm checking if the interval from -1 to 3 is the solution of the inequality. So let's test something from that interval. Will make it easy. Let's test x equals 0. And I'm plugging it into our inequality. So again, inequality was x plus 1. So I'm replacing x with 0, so I'm getting 1 plus 1 times, oops, sorry, why I did that. Let me, on the tab, let me put the inequality. So inequality is, so everybody see from where that comes from. Original inequality was x plus 1 times x minus 3 times x minus 5. And that should be positive, greater than 0. That's what we're testing. Okay, so we're replacing x with 0. So we have, just put that in red, 0 plus 1, 0 minus 3, times 0 minus 5, and you just have to check if that's greater than 0. So you have 1 times -3 times -5. Okay, and that will give you -5, 15. And 15, it's definitely greater than 0. So here, yes, this is our solution. Okay, definitely. That interval, yes. And again, let's repeat the same work 2 more times. Next one. Here I'm going to test number which is between 3 and 5, so test x equal 4. Let's plug it in. So we have 4 plus 1 times 4 minus 3 times 4 minus 5. And again, we're checking if that will give you something positive. So 5, we're getting 5 times 1 times -1. And that will give you, again, it's a multiplication, that will give you -5, -5. It's not positive. Okay, so this is not true. So interval from 3 to 5, it's not the solution. And I'm going to check one more. Okay, I'm going to check if interval from 5 to positive infinity is the solution of that inequality. Okay, so here test x equals 6. Again, 6 belongs to that interval. So we have 6 plus 1 times 6 minus 3 times 6 minus 5, and that should be positive. Check if that's greater than 0. Okay, so we have 7 times 3 times 1, definitely it's positive. We have 21, which is greater than 0. Yes, that's true. So interval from 5 to positive infinity, it's the solution. So let's write down final answer. Okay, so the answer, solution of this polynomial inequality is interval, and again going back from -1 to 3, union and from 5 to positive infinity. Okay, I'm going to stop recording. I'm making the videos short, so it's just uploading faster. Okay guys, I will provide one more example in the next video. Thank you for watching.